Okay, practice problems. A rock is thrown horizontally at 10 meters per second off of a 150 meter sheer cliff. What is the range? So by range, remember that just means dx. It's looking for the distance. All right, so let's make a good drawing. For all of these, it really does help to have just a general sketch of what you're doing here. So this one's coming straight off this cliff, this way, right? And it's going to come down here, land about there. We're looking for dx. That's what we're after here. It says that the cliff is 150 meters high. So from there to there. And v, well, which v would this be? So it says 10 meters per second. That's going to be velocity only in the x direction because it's going horizontally off the cliff. So vx is going to be equal to 10 meters per second. Okay, now what you're going to do, make your table. So the table is important. Oh, make it a straighter line than mine. So we got in the x direction and in the y direction. So in the x direction, we got Vx is equal to 10 meters per second. We've got, well, we don't have dx. That's what we're looking for. That's the final goal here. And then t. We don't know t either. I have a feeling that we are going to need to find time on the other side, right? Because they're linked. So like they're the only thing that's common between the x and the y. So in the y direction here, I'm going to write down vi, vf, t, a, and dy. Maybe I'll put y's by those two. All right, so do we know any of these things? Well, I know that the acceleration is negative 9.81 meters per second squared. I know that my distance in the y direction is going to be negative, and that's a big one because everyone forgets that, negative 50 meters. I need one more thing. What else do we know about the y direction? Well, we know the initial velocity in the y direction is 0. Right? That it's moving, but it's not moving in the y direction. All right, so we know three things. Now we can find the fourth. So we are looking for time because time is the same for both, right? So I can make that jump across there if I figure out time. I'm going to use a formula that doesn't even have VF in it. So I'm going to start off by going dy is equal to VIT plus 1/2 AT squared. Now this becomes a little easier because VI is equal to 0, so this term becomes nothing. And I'm left with dy is equal to 1/2 AT squared. If I rearrange this formula and solve for t, I get t is equal to 2 dy over a, and then take the square root of that. So t is going to be equal to square root of 2 times negative 150 meters divided by negative 9.81 meters per second squared. Now remember, if you don't get a positive underneath the square root symbol, you did something wrong. You can't get a negative under a square root symbol. Okay, so the time is equal to 5.53. Oh, my writing's a little weird. 5.53 seconds. Okay, so I figured out my time. That's kind of the hard part. So now I know my time is 5.53 seconds. So then now it's like I'm jumping across this border here because that's the same. So this is also 5.53 seconds. Now I just need to use my simple formula of V is equal to D over T. We'll make that red. So then Vx is equal to dx over t. And if I'm looking for dx, that's going to be dx is equal to vx times t. So dx is going to be equal to 10 meters per second times the time we just found of 5.53 seconds. So dx is going to be equal to 55.3 meters. And that's my answer. All right, hopefully you guys are doing all right with this stuff. Okay, the other type of problem now is when something's being kicked at an angle or shot at an angle. So first thing is to make a good picture here. All right, so when you're doing these ones, here's my kind of general picture I have going. Some people get confused about the vector thing here, and they'll be like, okay, so I had like a line that goes like this, and then then it goes back down or something like that, right? I've seen some kind of funny drawings. It's not really how it works. The green line here would be the path of the ball. The red line is the velocity vector. So if you can like keep track of that ball right when it was kicked, that's just the direction that the ball would go. So that's the vector, not literally the path of the ball. All right, so it says that it was going 15 meters per second at 40 degrees. What is the maximum height of the ball? So we're looking for this. So in these ones, what we need to do is we got to split this up into its x and y components. So make that color, and maybe the other one that color. Okay, so Vx is just going to be 15 times cosine of 40 degrees. So Vx is 11.49 meters per second. Okay, Vy in the Vi in the y direction. I did that backwards. Vi in the y direction is going to be the same thing, but just sine instead, because it's the opposite side. So it's going to be 15 times sine 40 degrees. So Viy is going to be equal to 9.64 meters per second. All right, so I've got the x and the y components of that velocity. Now let's make our table. So in the x direction, I've got Vx, we're going to have dx, and we're going to have t. Vx I just figured out. It was 11.49 meters per second. I've crammed this a little too much. Okay, on the other side I got Viy, Vfy, t, a, and dy. And then what else do I know? So I know Vi in the y direction now. I figured that out. That was the orange one over there. It's 9.64 meters per second. I always know acceleration due to gravity. That's kind of a gimme every time. Negative 9.81 meters per second squared. And I'm looking for the range, right? So that's that's my goal in the end. I need one more on the y side, right? Do I know anything else? Well, this red dot that I have up here, does that tell you anything about the y direction? Yep, it tells us that Vf in the y direction is 0 at that point. So that's kind of an easy one though. I can just find at that point, I can figure out what dx is equal to. And that would be dx up until right there. And then when I'm done, I just need to multiply that by 2. So that'd probably be an easy way to do it. The other thing you could do is I could say, I could take the whole thing into account, and I could look at this point, I could look at the whole thing, and then I know that Vf in the y direction would be the same as this, but negative. It's going to be going down. Either one though. I'm going to do the one where we make the top equal to 0. I find that just a little bit easier. So let's do that. So Vf is equal to 0. Now I'm looking for time. I'm going to use the equation that doesn't even have dy in it, which is going to be this one. Acceleration is equal to Vf minus Vi over t. So rearrange that. That becomes t is equal to Vf minus Vi over a. So t is equal to 0 minus 9.64 divided by negative 9.81 meters per second. And that's going to be 0.983 seconds. Okay, so I got my time figured out. Now there's really two ways you could do this too. I could just multiply the time by 2 and then find dx. Or I could figure out dx, like I said earlier, up until this point, and then multiply that by 2. Either one doesn't matter. Since I said this already, let's do that one. We'll find dx up to that point. So that's going to be dx is equal to vx times t. So dx is going to be equal to, my vx was 11.49. My time was 0.983 seconds. So dx is going to be equal to 11.29. And then the last thing I want to do is multiply that by 2 to get the whole distance. So times 2. So dx is going to be equal to 22.6 meters. Okay, there's your answer. And I forgot to find what the maximum height was. Sorry, were you guys wondering what I was doing? I figured out the range. I didn't figure out the maximum height. So hopefully you kind of were able to figure out what I was doing while I was making that video there. I'm going to leave the maximum height just for the length of the video. You would find the maximum height just by figuring out dy at that point. So you've got 3 things. You just have to use the form or the equation to find dy. I would probably use the equation without t, so vf squared minus vi squared plus 2ad. I'd probably use that one. Okay, so I'll let you guys go ahead and figure out what the maximum height was. And that's it for the practice problem. So go ahead and do the hand-in assignments. I've got some tougher ones here, 10, 11, and 12. There could be a question on the on your guys' test that does have, you know, these type of questions. There won't be many, but it is possible. So make sure that you give these ones a good try too. Don't just say, oh, they're too hard for me. Okay, so do those. So I'm going to make this building a projectile machine an optional one that you can do. This is going to be between you and your teacher. So if you and your teacher make some kind of agreement about, I don't know, what this might be worth for marks, or whether it's just for fun, or whether it is used as like a makeup type of a mark, whatever kind of agreement you guys come to, you can do this. Yeah, but I'm not going to go any more into this one. So if you want to do that, see your teacher and see what they say. Okay, that's it for that video. And that's actually it for this unit. So make sure you guys do the unit review.